Hi, I'm Kevin, and I'm going to be talking about the backend to our project. So if you don't remember us, we're PC Chop Shop. Quick refresher, our project is a web application that scrapes data from right now eBay, Craigslist, and Facebook. We're looking for information specifically about used PC parts. Uh, we're most interested in using this data to track the historical prices of the PC parts so that we'll know whether an individual part is a good deal or not. So we have made some progress since the last update. As far as the backend goes, our biggest accomplishment was that we have a remote database now. For this, we used Amazon Web Services, and we have a Postgres database hosted there. We also added a few tables to the database. They just have basic information about the most popular 10 to 20 PC parts. Uh, so once we get the item of the title parsed through, we can use these tables to identify the part in the listing. Uh, Once the part is identified, we can then track the average price. We did begin work on parsing, but we had to spend some time fixing the eBay search, which I'll touch on a little later, so we're not as far ahead on parsing as we'd like to be. So the first thing we'll need to accomplish to move forward is the parsing or filtering of our item titles. So this is time consuming as far as coding and testing goes. We need about 10 different filtering functions, one for each part category. Inside those functions, we have to have code that identifies each part, and we have a minimum of 10 parts for each category, uh, so it can take some time. Uh, Another thing we want to accomplish moving forward is determining sold listings on Craigslist and Facebook. For eBay, it's pretty easy. They'll tell us, but for Craigslist and Facebook, they don't really have a way to determine that. So we might just have to see if the listing isn't there anymore, and that's the best we can do. Lastly, we want to have a way to display our data to the users. So we'll have to have some kind of data container where we can gather all the relevant information in a way that it's easy to use for the UI. So I was mentioning earlier how our eBay search functionality is actually broken right now. I think this has happened because eBay updated their protocols so that only HTTPS connections are allowed. I've been trying to modify the eBay SDK files to use HTTPS, but I've been unsuccessful thus far. Yesterday, the library said that it was actually updated to force an HTTPS connection, but it's still not working on our code or the sample code from the repository. So I think moving forward, the only solution to that may be to craft our own connection requests like you would with boilerplate Python. But I'm just kind of assuming that that's going to give us issues, and so that's why I tried modifying the existing code and updating the library version first. So that's been our biggest roadblock for the backend thus far. Another thing I touched on earlier was that there is no way to determine if a listing is sold on Craigslist or Facebook. Um, so we may run into a few issues in this because just because a listing isn't there anymore doesn't mean it actually sold. Uh, and for tracking the historical price, what we really want to focus on is the listings that actually sell. Lastly, we need to make sure that our filtering is good enough to catch things like combo items or listings that have incorrect information. For this, we really just want to make sure that we're testing all the cases we can think of and just making sure that our functions are returning correct results. So here's just a screenshot of some charts about our database. You can see there are some clients connected, we're doing some read-write operations and so on. This is really just to show our remote database and say, hey, here we have one. So here's a screenshot of pgadmin, which is like the dashboard for Postgres databases. At the top, there's a SQL statement that selects all of our entries in the SSD table. This table is one of the ones we're going to use to identify the parts. We've got a primary key, which is just an auto-generated integer, then make, model, size, and our count, which is all zeros for now. I think in the future we're going to add a price column to all the tables like this because I think that's the easiest way to keep track of the current prices. And then we're going to have separate tables to keep track of historical prices. So that's pretty much all there is to talk about the backend.
One of our stretch goals was to be able to add Facebook to our application so that way you can scrape the web for listings on Facebook. And there isn't currently a public API available, so we had to kind of create one ourselves. And so that's the first thing we accomplished is we were able to do that. So right here, it searches for GTX in Denver. And if I run that, it'll grab me the third listing here. And so in this case, we have a 1060 6 GB for $200. If we want to grab the first result, save that, and then run it again, and it grabs the 760 graphics card for $100. And this is actual live data from Facebook. And so some of the roadblocks and failures is one thing we're going to have to figure out is how to grab the location from the current user who's using our website. Because right now you could just basically type in cities and stuff, so we're going to have to find a reasonable city or location to grab data for that user. And then lessons learned on this project is I definitely learned how to use regular expressions as well as scrape data from non-traditional web pages. And what I mean by that is if you look at Facebook source code, as you can see, there's not, it doesn't look like a traditional HTML page, as in there's not lists and unordered lists or ordered lists, there's not divs or any sort of script tags like that, or I guess HTML tags. All of the relevant data is, or all of the relevant data is actually inside these script tags. And so if you look at something like price, go through here, so I find something like this, formatted price, like $100, this is reasonable data that we want. It's all nested inside these script tags. And I believe it's PHP that's running on the back end of Facebook that's actually grabbing that stuff. And so the first thing I did, because I was getting this massive page source code, I basically found all the script tags, and I then found that 16 had the most useful data as far as what we needed out of those script tags. From there, I then did a regular expression to essentially add quotes to the keys inside these objects. Because if you look at this price tag, it's not in quotes. And JavaScript, or I guess JSON objects, they need to be in quotes. So I had to write a regular expression to be able to do that. And that's something I've never done before, so that's something I learned how to do. I also, when I was writing regular expression just to find the JSON objects inside these strings, at first I was trying to basically find an open curly brace and then close it with a closed curly brace. But as you can see, if JSON objects are nested, it's going to close it before that JSON object's valid. So I wasn't able to do that, and I needed to use decoder in order to find the first open curly brace and then get that entire JSON object, even the nested ones inside of it, which worked out very well. Then these are just some more regular expressions I needed to use, basically converting it from a PHP dictionary to a JSON object. So none becomes null, capital true becomes lowercase true, same with false. And then something that I didn't anticipate that I needed to do was actually some users had a listing that looked like this. So it's this is the marketplace listing attribute, and it says mountain of 1080 Ti's, but instead of using an apostrophe, they used a quotation mark in place of an apostrophe, which ended up um, ended up breaking the string too early. So then I had to write another regular expression. So that's what it should have been. It should have been mountain of 1080 Ti's, and then everything works. So I had to write another regular expression to kind of fix that problem. So as you can see here, mountain of 1080 Ti's with a quotation mark. And then you just swap that out with a single quote. The issue with this is you're trying to find a quotation inside of a set of quotations, and that's very difficult to do because technically, if you look over here, this quotation right here is a quotation inside of these two quotation marks. But obviously, this one's valid. So really, the question we were asking is, what is a quotation inside of a non-valid set of quotations? which would be over here, and then we replace it with an apostrophe. So after we got all that working, all I had to do was basically look at the data, which I just put into a JSON viewer here, traverse through all of these JSON objects and arrays until you could find some useful information. So all of these edges are actually the listings. And inside these listings, you can see stuff like formatted price, the list photo, as well as the location and the name of it right here. So after we got all that done, all we need to do now is actually integrate it with our front end as well as the server, so that way it's running on the server and not on my local machine, and then people will be able to use it.
Hi guys, I'm Jordan, and I'm going to be talking about our user interface and where it currently stands, and COVID-19 and how that has affected our group's workflow. First things first, let's talk about the user interface. Our user interface has not changed drastically since our last presentation. As you can see, we still have the search bar front and center. After the user types in their search, our program will return all of the search results it was able to find across multiple platforms. I've got a couple of examples here so that we can see individually how the web pages are returning. Right here, we can see some examples from Craigslist. Here in just our Laramie area are a couple of results that showed up for NVIDIA GTX. At the same time, our search would return all of the eBay results. And of course, we can't limit that just to Laramie, so this is going to be nationally all the time. Our hopes are that we will be able to build in functionality very soon that users will be able to click on any one of these items. So say the second one, Zotac NVIDIA GeForce, they'll be able to click on that and it will link back to the eBay page that has all of the product description and allows them to purchase the item right there. This saves us a lot of difficulty, as then we don't have to deal with being a middleman, dealing with payment, processing, anything like that. We just ship it off to eBay, and then users are able to buy the product that they found through us quickly and efficiently. We're also hoping to add graphs and charts for the historical database. However, we have not done that, as the backend for the historical database is not quite finished. Once that's finished, we'll start building all of the beautiful user interface so we can display all of our results properly, and so the users are able to see the average price of products visually and easily. As far as COVID-19 goes, it has had a pretty large impact on our group. The biggest thing is that we're no longer meeting in person. We found a way around those in-person meetings by utilizing Discord. Discord allows us to have multiple channels so that we can discuss code, have general conversations, schedule meetings, and things like that, as well as provide links to each other for important and relevant articles or information. Because of COVID-19 and all of the workarounds we've had to figure out, we have fallen 1 week behind. We are catching up to our planned schedule, and we don't believe that it has affected our success rate. We think we will be able to complete our project on time and to the specifications that we expected to reach. COVID-19 has also complicated our presentations, just like this one. We've decided to pre-record our presentation individually and then send it all together and have it edited. We believe that this is the easiest and the safest way to provide our presentation to you guys and meet all of those presentation deadlines. So coming up, Jacob's going to talk about our successes, our roadblocks, what we've learned, and where we're going to go from here. Thank you.
So I'm going to talk about our successes. Our first success is with the eBay search. We successfully created a function that utilizes the eBay API to search eBay results, collect the data, and present it to our users. This is done, obviously, using the finding API that eBay provided. Our next success came in the form of Craigslist search. We found the third-party Craigslist API that allows us to search by keyword and location and all the filters that Craigslist offers. On top of this, we recently got a Facebook API working. Most of this was done by Austin. He developed an API that allows us to access the data on the Facebook marketplace. Now, Facebook is not a fan of scraping. They even go out of their way to prevent it. So the fact that we got that working was a pretty big success. Definitely a confidence booster. On top of that, we've gotten 2 databases at this point. So our first database, which I'm sure was discussed, is the database which stores all our results from our searches and our scrapes. This allows us to present the data to the user, On top of this, we have created a historical database. Now, currently our historical database is not linked to our front end, but it is up and running. Our historical database is currently going to be used to track top-selling products and their prices. On top of this, we've made a couple steps towards part identification. We've deduced a few methods in order to properly identify parts. We've done this using the data that eBay provides and the information we get from Craigslist and Facebook. This is done essentially right now by utilizing the keyword, which will be the title of the product, and whatever other information is provided. So with eBay, you can get all the information from the posting. This includes things such as chipset or manufacturer. So say someone searches a GTX 1080, we can check that information with the information of the posting, and if the chipset says GTX 1060, it kicks it. So this kind of helps us sort through some parts. It's got a long way to go. We still haven't handled combo items, and there's still some bugs to work out where things aren't getting caught when they should be, but it's a step in the right direction. Next, I'm going to talk about our change to our plans. So last couple weeks have been pretty crazy. We've had to change a few things, but with the back end, first thing first was with the historical database. We realized pretty quick that we needed to change the scope of what we wanted to track. So we decided to, instead of trying to track every part and provide this data for everything, we tracked approximately the top 20 items of each category, such as CPUs, GPUs, etc. This allows us to keep our information relevant and accurate, on top of that, without filling the database with information. On top of that, we modified how we're going to track and store the prices and sold parts. So initially, we had thought we were going to basically scrape every time a graphics card or something was searched and populate that information then. This would result in a ton of pings and pretty much issues across the board. On top of scraping for results, we'd be going through that data and trying to increment our counts and our price counts and all that. So we changed that. We've been looking at updating daily instead of every time a search, so that it's not constantly updating, but it would be accurate to 24 hours. Furthermore, we have discussed potentially changing from tracking sold items to just tracking the average daily price of items. This was done because eBay provides an API for sold items, so it's very easy to get this information. But with Craigslist and Facebook, this information is, one, not available. Usually posts on these sites get put up, and when they're sold, they get taken down. So that information is hard to grab before it's gone. And on top of that, there's no easy, surefire way to get that information. Now with Facebook, we're considering possibly limiting it to the only first page results. This is done to filter out some of the poor results that come back with Facebook. It's similar to Craigslist. Once the results relevant to your search are gone, it just starts showing you random postings. So that would help us filter out bad results, as well as Facebook not being a fan of scraping. We don't want to scrape everything we can, just because there could be some issues with Facebook's terms and conditions and things like that. So we don't want to poke the bear. Next, the user interface. So initially we wanted a separate page on our site where you could click on the item and see the item's details, similar to PC Part Picker. This is easier said than done, and we've adjusted this given time restraints and the amount of work that would have to go into that, so that when you select an item, it will take you back to the original post, whether that be Craigslist, eBay, whatever. And that is not implemented yet. That decision is made, and all that it takes is a stored URL. It shouldn't be too easy to implement, and shouldn't set us off track at all. Next is lessons learned. With the back end and the historical database, a lot of lessons were learned really early on. First off, tracking sold items on eBay. Super easy, like I said, with the API, but everywhere else it's tedious and pretty much impossible. On top of that, we learned that product filtering is going to be a big factor in the success of our historical database. If we can't accurately identify product names and correct products, then our information and our data that we present is going to be completely wrong. Furthermore, there are a ton of used PC parts on the market, so we actually ended up having to go in by hand, like I said, pick the 20 parts and enter that in as information that we wanted to track. And you can't possibly track all the PC parts within our scope. On top of that, things change. A CPU could not sell very well, but then the moment they cut $50 off, it's a top seller. So there's definitely some lessons to be learned there. On top of that, with the UI, we quickly learned that in order to have a usable UI, you have to have the back end done. Trying to design a UI with no back end or with limited back end doesn't really work because the UI designer doesn't know what they're trying to design for, and that makes it a pretty difficult task. Finally, our confidence and on track. Speaking for the whole group here, I think we're all relatively confident that we will have a successful final product. Although we are slightly behind, we're still making constant progress and haven't ran into any real problems yet that we couldn't figure out a way out of. On top of that, with Austin's success with the newly created Facebook API, our confidence is up. That was a stretch goal, and that's a great thing to have done. Definitely some more things that need to be done before we can focus on that, but we're in a good spot right now for this kind of end run. Currently, for on track status, we are approximately a week behind, but we are slowly catching up to schedule. Although we are behind, it has not affected our confidence. Furthermore, we aim to be back on track by next Wednesday so that we can reach a stable final product and potentially hit a few more stretch goals. Thanks.